So let's now talk a bit about the percentages of data and where they sit on normal distribution curve. Because a normal distribution and these markers, these vertical lines you see here, split our data up based on percentages. Now, this is the information you'll have on your formula sheet for your exam, a copy of this curve, and this information here, which we're going to break down for you right now. So let's do it. These numbers across the bottom that you see from -3 up to 3 on this diagram are what we call the z-scores. Now, we'll talk more about them in a future video, but for the moment, they basically represent standard deviations. So from 0 to -1 is one standard deviation. So these values, which we call z-scores, are basically representing the number of standard deviations away from the middle. And the standard deviation is just a measure of spread away from the mean. The distance between the vertical lines here is one standard deviation. So I would say from 0 to 1 here, in terms of my z-scores, represents one standard deviation in my data. So looking at the info we're given, approximately 68% of the scores sit between a z-score of -1 and 1. So on our graph, that's this space in here, right? 95% sit between -2 and 2. So if our data was within or between these two bounds, the z-score of -2 and a z-score of 2, 95% of our data in a normal distribution will sit within that range. And finally, you can see from our table here, or from our information, 99.7% of all the scores in our data of a normal distribution will sit between a z-score of -3 and 3, which is, most of it. So this middle section, this middle 68%, okay, which is from z-score of -1 to 1, I can see that it's split in the middle, it's symmetrical. So if I was to split that, I could see, well, this part between 0 and -1 is 34% of my data. With a z-score from 0 to 1 represents also 34%. So when I add them together, that's where my 68 comes from. Working our way out, we can apply the same idea. If 95% goes from -2 to 2, and I take out the 68% in the middle, I can see that, well, 13.5% sits in here, and 13.5% here. And let's continue the same idea. If 99.7% goes from -3 to 3, then these little wedge bits at these sides here must be 2.35% each. So if I add them up, 2.35, this, and this, if I added them all together, that would come to 99.7. So it just gives an idea of each little strip of one standard deviation, how much data sits within that. So let's have a look at what this means in terms of a practical application or a question. We've got a laptop, Toddy's Laptops sales service, and the delivery time. So if we were to collect the data of how quickly these laptops get delivered, it would come out as a normal curve. Okay, and we're given some information in this question that the mean, or the average, is 6 days, and every standard deviation is 2 days. So I'm going to take this and I'm going to replace some of my data here, and we're going to put our numbers on top of it. So we've got a mean of 6. We know that in a normal distribution, the mean sits in the middle. We know each one of these strips is one standard deviation, which we're told is 2 days. So I can add these numbers to represent 8 days, 10 days, 12 days. And I can also go down as well, representing the 4, 2, and 0 delivery dates, because every one of these is one standard deviation. Let's look at question A. What percentage of laptops have delivery times between 2 and 10 days? Well, between 2 and 10 days, that is this span here. And I know from what we looked at earlier, that covers 95% of the data, going from this strip up to this strip. In other words, 2 standard deviations down and 2 up. So 95% of laptops get delivered between 2 and 10 days. What percentage of the laptops have delivery times greater than 10 days? Well, that's this piece up here. It's everything from the 10 upwards. So can I work out a percentage for that? Well, let's have a look and see what we know. From the middle down, because it's symmetrical, that covers 50% of the data. This strip here now, so the bit between my mean and where my 10 starts, covers, well, 34 plus another 13.5. So it covers that bit and that bit. And if I add them together, that's 47.5. So if 100% of my data is the whole thing, then what's left up here must be 2.5%. So I've took 100%, take away this 50, take away this 47.5. The remaining bit is this section. 2.5% of the laptops get delivered more than 10 days in delivery. Finally, question C, it says, look, in 1 year, if there were 200 deliveries, how many of them get delivered in less than 4 days? So let's go back to our chart and have a look. Where's that section that represents 4 days or less? And you can see that it's from here down. We're going to apply the same idea. Well, in this case, I know that my 50% from the middle up plus this 34 representing this section here. So I've got 50 and 34 gives me the 84%, which means this bit must be 16. So from here down to make up my 100%, that must be 16% of the deliveries in there. Now, what is 16% of 200? If there were 200 laptops delivered and 16% of them are 4 days or less, I can do my percentage calculation, writing 16% as a decimal, 0.16. 200 times 0.16 gives me 32 laptops sit in this section, were delivered 4 days or less. So there's a practical application of how we can use the percentages that we're given on a normal distribution to apply in a practical scenario. Well done.